So depth first search is a graph traversal that will also produce a spanning tree as a final result. Okay. Spanning tree is, you know that spanning tree is a graph without any loops because graph has a loop. So spanning tree now will have no loops. Okay. So in this breadth first search, we are using Q data structure. And what is the size of Q's data structure here? The size will be equal to maximum size of total number of vertices in the graph. Q size will be equal to total number of vertices in the graph to implement DFS. Okay. Now, what are the steps to implement DFS? The first one is to define the Q. Q size should be equal to total number of vertices in the graph. Then you can select any vertex as a starting point for the traversal. So visit that vertex and insert it in the queue. Okay, whichever vertex we are visiting, insert that vertex into the queue. Okay, now what we have to do, we have to visit all non-visited adjacent vertex of that particular vertex. In the previous case, we are visiting any one of non-visited. Okay, in this case, we have to visit all non-visited adjacent vertex of that particular vertex, whichever we are putting into the queue. Now, all this vertex also we have to insert into the queue. Okay, so once we have inserted all the queue, so since the the first element, first vertex we have insert in the queue have no new vertex to be visited, yes or no? So that is why we remove that the vertex, the first vertex, whichever we have inserted into the queue, because we have visited all the adjacent vertex of that particular vertex. So first element will be removed from the queue. Now the second element will become the first element, yes or no? So now we have to take the whichever we have inserted into the queue, and we have to visit all its non-visited vertex, and that vertex should also be inserted. So that is the step 3 and 4 will be continuing till the queue is empty. Empty means we are visiting all non-visiting vertexes whichever we are inserting into the queue. Okay, so when the queue becomes empty, then finally we are getting a spanning tree which has no edges, no loops. Okay, so for example, if you take A, so insert A into the queue. Now, what are the adjacent vertices of A? The adjacent vertex of A is BED. BED will be entered into the queue. Now, A don't have any adjacent vertex, remove A. Okay, next, what is the vertex to be visited is B. Now check B. What are the non-visiting vertex of B? Is C, only C. Non-visiting vertex of B you have to take. B is having C, yes or no? So insert C here in the queue. Then since B does not have any new vertex to be visited, okay, E is also already entered, no? That is why we are not visiting, which is not visited, that only we have to consider. So C is not visited, so we have to consider C only. Okay, next, what is the next vertex to be visited is that we will be getting from the queue. AB we have completed, no? Next, E is the next vertex to be visited. Okay, now for E, what are the non-visiting vertex? Here is F only, because C already we have visited, so we are writing F here. Now, what is the next vertex to be visited is D. Okay, D, if you check D, all the adjacent vertex of D is already visited, so we have to remove D from the queue. Next vertex to be visited is F here. Okay, so if you just check F, what are its adjacent vertex? C is already visited. Now we have to visit only G. G will be entered into the queue. Okay. Next, since F we have visited all the vertex of F, F will be removed. Then we'll be checking C. C vertex, adjacent vertex of C is already visited. So remove C also from the queue. Then finally, what is the final vertex we have in the queue is G. So adjacent vertex of G is also already visited. Remove G, like that. Till queue is empty, we have to complete this process. Okay, this is the DFS we'll be getting for this particular graph. Okay.